All right, cool. I'm gonna skip those 4. They seem like it's for the mainly the student, like find the errors and correct them, but we can come back to it if you guys really need me to. Okay, so we'll just jump ahead and get started with applications with fractions. And if you work through these or if you've done all the fraction homework already, cool. Just follow along, or if you want, start on the next lecture's homework, the order of operations. Okay, and let me do that, maximize that. I have enough room to write, I think so. Okay, so first up, Dolores sold candy by the pound. The first person who came into her store bought 2 1/4 pounds of gumdrops. The second person who came into the store bought 5 3/4 pounds of jelly beans. How many pounds of candy did Dolores sell to her first 2 customers? All right, guys, what would the operation be here?
Addition.
Addition, good. So we would have, come on, pen. There we go. We would have 2 1/4 plus 5 3/4. And can I actually add these mixed numbers?
Yes.
Good, because they have the same denominator, right?
Yes.
So we would get 7 4/4. But what would that convert to?
A 1.
A 1. So you would actually get 7 plus 1. So they bought 8 pounds of candy total. Or if you guys wanted to think out of the box and absolutely hated fractions, 2 1/4 is what decimal number?
$2.25.
2.25. And 5 3/4 is what decimal number?
2.75.
Well, 5.75. Okay.
Oh, I wasn't counting the
You're
whole
good.
number.
No, you're good. You're good. And then add them up, and guess what we get? 8 pounds. So there's always a way around it, right? Okay. 19. In language arts, the class was assigned to write a team paper. Each team was to write 5.5 pages for the combined paper. When all the teams put their papers together, there were a total of 44 pages. How many teams had worked on this paper? What operation would this be?
I said division.
Good, division. So it would be 44 divided by 5.5. Okay, but now we know if we do this operation, we have to change this into an improper fraction. So using that fraction trick, you would get 5 times 2 is 10. 10 plus 1 is 11. You would get 44 divide 11 halves. And then you would flip or multiply by the reciprocal of that fraction. Get 44 times 2 over 11. And you can cross cancel. You have 44 and 11. So I can take an 11 out. That'll be 4. If I take an 11 out of 11, that will be 1. And we end up with 4 times 2, which gives us 8 teams. Boom, boom, boom. Perfect. Okay. Everybody good with those two?
Yes, Professor, I have a question. So I see that you're actually putting like 18, the answer was 8 pounds, 19 was 18. So I just put the number, but you do want us to be specific.
I mean, if you put the number, I wouldn't count off, but I mean, since it's asking like what they bought, it's always nice to put a label to your answer. Because I mean, the question does say how many teams worked on it. So 8 teams, how many pounds did they buy? 8 pounds. But if you didn't put it, I wouldn't knock you for it. So it's just my habit. I do labels. I teach business math. So we have to say like if they made a profit, cost to revenue, and students just like to put a number. I'm like, what does that number mean? And they're like, oh, I guess that makes sense. All right. So again, wouldn't knock you for it here. All right. Dennis's new dog weighs 127 3/4 pounds. His friend's dog weighs 94.5 pounds. How much more does Dennis's dog weigh more than his friend's? What operation will we have here, guys?
Subtraction.
Subtraction. 127.75 minus 94.5. All right. So, well, we can't subtract these now because these are not the same fractions, but it is very possible to get a common denominator on this fraction that matches that denominator. What could I multiply this fraction by to get a common denominator of 4?
2.
2. So if I multiply this by 2/2, we'd end up with 127.75 minus 94.25. And now can I subtract these two fractions or these two terms?
Yes.
For sure. All right. 127 minus 94. What is that? 31? I think so, right? 31.75 minus 2/4 gives me 1/4. So Dennis's dog weighs 31.25 pounds more.
33, sir.
It's 30,
Oh, 30, sorry, 33. 7 minus 4 is 3. Where did I get 1 from? See? Good. Somebody has to catch my mistakes. Boom. Okay. Awesome. 21. On their vacation trip last summer, the Pace family got 30.5 miles per gallon of fuel on their trip from home. On the return trip, they only got 17 7/8 miles per gallon. How many more miles per gallon of fuel did they get on their way out than on their way home? Okay, so what would this operation be again?
Subtraction.
Subtraction. Good. 30.5 minus 17 7/8. Okay. So in this situation, it's not going to work as nicely as the above. If we try to get a common denominator of 8 on this fraction, we would multiply that fraction by 4/4. But then something would happen. If I multiply that by 4/4, you would end up getting 30.4/8 minus 17 7/8. Yes, we now have a fraction with the same denominator. But if I subtract these two fractions, 4/8 minus 7/8, I get -3/8. And can that happen?
No.
No. So what is another way around this?
You have to make improper fractions.
Make improper fractions. All right. So 30.5 and 17 7/8. So we'll make improper fractions. First up is 30.5. 30 times 2 is 60. 60 plus 1, 61/2. Minus, what is 17 times 8, guys?
136.
136. And 136 plus 7 gives me
136.
1, and then add the 7 and you get 143/8. Okay, cool. And now we need that common denominator of 8. So what number will I multiply 61/2 by?
4.
4.
4. Good. Multiply by 4/4. And then 4 times 61 should give me 244/8 minus 143/8. Make sure my math is correct because I'm doing this in my head. Okay, and then 244 minus 143. We can now subtract these. They have the same denominator. I get 101 over 8. But we want to put this where it makes sense. So we need to convert from improper back to mixed number. So we say 8 into 101. And how many times is 8 going to 101?
12 times?
12. Good. 8 times 12 is
96.
96. We get that remainder of 5, and we get that they got, what is it? How many more miles per gallon of fuel did they get on their way out? They got 12 and 5/8 miles per gallon more. Beautiful. All right. Everybody good so far? Right, get in there. 22. Jerry bought 12.5 pounds of candy to share with his friends. If he gave 2.5 pounds each to 3 friends, how much candy does he have left? So what would we do here, guys?
Divide.
Divide. Well, I wouldn't divide because it's saying that he gave 2.5 pounds each to 3 friends. So if he gave 2.5 pounds each to 3 friends, that would be more of what?
So we're going to subtract.
We will definitely subtract from the total amount, right? We have 12 and 1/2 minus, so you have to think about it. He gave out 2.5 pounds 3 times.
So you have to times 2.5 by 3 and then subtract that from 12 and
Very
1/2.
good. Very good. Okay. So now it's going to be 12 and 1/2 minus 3 times 2 and 1/2. Okay. So here, remember, if you are going to distribute this 3, remember that a mixed number is written as, or also written as 2 and 1/2. So not only would that 3 need to go to the 2, that 3 would also go to that 1/2. Or if that's just too complicated, then what we'll do first is change everything into an improper fraction. Which way do you guys want to go about it?
Can you show us both?
Yeah, I can show you both. Okay, and let's see if they actually come out right. Okay, so this means I would have 3 times 2 plus 1/2. So the 12 and 1/2 would stay the same. And then we would have minus, and if we distributed this 3 times 2 is 6, and 3 times 1/2 is 3/2. So actually, this may make it more complicated because can we actually subtract these 2 fractions?
Nope.
No, because they'll be negative. Now I do have a fix for that, but that will go down another road. So actually, I guess our best bet is changing them into improper fractions and then subtracting. So I can explore that in a second when we come back to it. Okay, so that method's not going to work then. Cool. So we're going to leave that alone. And now we'll just convert to improper then. 12 times 2 is 24. 24 plus 1 gives me 25 over 2. Minus 3 times, we convert here. 2 times 2 is 4. 4 plus 1, 5/2. Now we multiply that 3 in there. And we get 25/2 minus 15/2. And now we can subtract these and you get 10 over 2, which, hey, that gives us 5, oops, ugly, 5 pounds left. Cool. All right. Everybody go with that one? That seems like the best bet. Like if I'll show you real fast, and then you can probably delete it out of your head if you want. So we had this when I set up the last one. It was 6 3/2. We cannot subtract them, which means I have to make this number bigger. So what I do is some reverse engineering type stuff with fractions, which probably is more steps, but it's actually pretty cool to think about. So remember that this is written as 12 plus 1/2. Well, what I'm going to do with that 12 is make it into 11 plus 1 plus 3/2. And now remember what I said is that 1 is not 3/2, sorry, 1/2. Now remember I said that 1 is a pretty powerful number. So I'll have 1 plus 1/2, and I'm going to change that 1 into the fraction of 2/2. So what we have is 11 plus 2/2 plus 1/2, which will give me 11 3/2. And now if I subtract 6 3/2, your fractions of 3/2 will cancel. And what's 11 minus 6?
5.
Boom. Look at that. So again, that's not out of box thinking, but it probably just involved more work. So use it if you want. But again, more methods to this madness. You're like, I'm not doing that. Okay, cool. Last one, 23. Joy and her friend wanted to do something different. They just decided to go to the track and see how many times they could run around the track without stopping. When they finally finished, their stopwatch showed that they each ran a total of 23 2/5 minutes. If on average, Joy also knew it took them 4.5 minutes to run around the track once, how many times did they make it around the track? All right, what is our operation here?
Division.
Division. Good. We take 23 2/5 minutes and we divide 4 1/2. And of course, we have to convert both into improper. So 23 times 5, what's that give me?
115.
115. So 115 plus 2 gives me 117/5. Divided by, change this one, 4 times 2 is 8. 8 plus 1 is 9/2. Okay, cool. So we have two fractions dividing each other. Now we know we can multiply by the reciprocal. So we keep the first fraction, change from division to multiplication, and flip the second fraction. All right. So here we can cross cancel if anything's possible. 5 and 2, nothing's happening there. But what about 117 and 9? Can you take a number out of there?
13.
Well, the biggest number we can take out is 9, which will make 117 into 13, right? So if I take a 9 out, that becomes 13, that becomes 1. And what I'm left with is 13/5 times 2/1. We get, making sure everything's right, 13/5, 2/1. We get 26/5. But now we have to put it into terms that are understandable. So long division, 5 into 26. We know that goes 5 times. 25 with the remainder of 1. And we get our answer as 5 1/5 minutes, right? Or how many times did they make it around the track? Let's see. When they finished, their stopwatch showed they ran that many minutes. It took them 4.5 minutes to run around the track once. How many times did they make it around? Oh, they made it 5 1/5 times around the track. All right, I'll just say around track. All right, and there you go. Excellent.
Professor,
What's
I'm
up?
sorry, quick question. So you know how you've got the improper fraction, and so you've shown the division work. Is that necessary to do that final step, showing the division work?
Right here?
Yeah.
No. If you can, well, you want to convert it to this, but if you don't want to show this part, that's totally fine.
Cool.
But yeah, but we don't want to leave the answer like this, because imagine telling that to somebody, hey, I ran 26/5 today. They would run away from you.
So
Okay.
do you only want us to answer like that for the word problems or even for like the regular question?
For the word problems, I would put them back as mixed numbers. But for other questions like we did on the notes, if it was improper, I didn't really convert them back. But if you want to convert them, that's just good practice, and I wouldn't mind. But I
Okay, thank you.
wouldn't take points if you didn't. Okay, cool. All right, and that finishes the fractions lecture. Yeehaw. So I'll stop on that one. And we can start with order of operations. Whoops, didn't mean to do that.